Hello, my name is Patrick Evans, and welcome to my video about Layer 2 switching and ARP. The objectives of this video is how a switch learns MAC addresses, how a switch makes forwarding decisions, broadcast domains, and address resolution protocol. Now, a MAC address is a Layer 2 device, and it's a physical address. That means it's built into the NIC when the NIC is manufactured. It's going to be 48 bits represented in hex in one of these three ways. IP addresses are Layer 3 address. They're logical, meaning they're configured on the device by the administrator or the owner of the machine. They're going to be 32 bits represented in dotted decimal notation. Now, the MAC address table is something switches use to decide how to forward incoming frames. They map MAC addresses to switch ports. They learn these MAC addresses by monitoring the source MAC address field of incoming frames. In this example here, we see switch 0 with 4 devices connected. Each device has a MAC address, and the switch needs to know which port to use to send Ethernet frames to the destination device. We can look at the example here and we can see that PC0 uses a MAC address ending in 7E13. And if I look at the MAC address table in my switch, I can see that I have an entry for 7E13. I learned it dynamically, and it's assigned to port Fast Ethernet 01. Therefore, any frame with a destination MAC address of 000B, BE66, 7E13 will be sent out port Fast Ethernet 01. Layer 2 broadcast frames are sent out all switch ports, except for the receiving port. The broadcast address is all Fs. They are not forwarded by Layer 3 devices, and broadcasts are primarily used for discovery purposes. In this example, we see PC2 sending a broadcast frame to the switch 0. When switch 0 receives this frame, it's going to go ahead and forward a copy of that frame out all active ports except the port it was received from. Router 0 will receive the frame, but it will not forward it. A broadcast domain is a group of devices that receive broadcast traffic from each other. In this example, we have two broadcast domains. We have the yellow domain and the blue domain. Notice how they're separated by a router. Any broadcast received by switch 0 will be forwarded out all ports, but when the router receives it, it'll receive it, processes it, but it will not forward it. I have another broadcast domain circled in blue. In this example, a broadcast generated by server 0 will be received by switch 1, but it will not be forwarded to router 0. Address resolution protocol is used to learn the MAC address of a given IP address. Our end devices and routers, they all have IP addresses, but to create that Ethernet frame, they need the destination MAC address. So they're going to use broadcast to learn that. So if a device wants to learn a MAC address, it's going to send a broadcast out, and the device that has that given IP address will respond and tell the originating device what the MAC address is. If we look at our ARP table on a PC, we can see that it's already learned, and it's created an ARP table mapping that maps the physical addresses to the IP addresses. And we can look at that. In this example, PC2 has a MAC address of 1633, and I'll see that right down here. 1633 maps to the IP address 192.168.1.13. Now let's look at the MAC address table of router 0. In this example, router 0 has already learned the MAC addresses for all PCs on this network. For example, if router 0 wants to send a packet to 192.168.1.13, it's going to use the Ethernet or the hardware address of 0001 64B3 1633, and it's going to send that frame out interface gigabit 000. Now that we've covered MAC addresses, ARP, and switching, let's move on to a lab example where we can see this in action. Now that we've learned about MAC addresses, IP addresses, and ARP, let's take a look at this in a lab scenario. So in this lab, I've got two local networks, LAN A and LAN B on the right. I've already configured the PCs. We'll take a look at that. If I go to the PC under the Desktop tab, I can look at the IP address configuration. I've already put in the IP address subnet mask and default gateway on all PCs. Now in the router, I've gone into the config tab, and I can go right to the interfaces and give it the IP address and subnet mask. And I've gone ahead and turned the interfaces on the router. So let's take a look at what our PC knows right now. So we'll go into our command prompt and type the command ARP-A. So right now the PC has no ARP entries. And in the switch we can take a look at that again. I'll go into the CLI tab, and in the switch I will go into privileged exec mode, and I'll type the command show MAC address table. And right now the switch only knows the MAC address for the router over here on gig 01, MAC address ending in D001. Next we'll take a look at the ARP table of router 0. So as I click on router 0, we'll see that router 0 only knows the MAC addresses of its own physical interfaces, 172.16.1.1, 192.168.1.1. It does not have any other ARP entries. Now, the last thing I want to look at is the web server. So let's click on that, and we'll go to the services tab, and I'll see that HTTP is turned on. And then from the desktop tab, I can look at the IP configuration and see that I've got the IP address, subnet mask, and default gateway configured. So I'll close this, and let's go ahead and just check our ARP table. And there are no ARP entries in the server. So let's go and see what happens when PC0 creates a web request to server 0. So I'll go ahead and go into PC0, and I'll go to the desktop, turn on the web browser. Once the web browser comes on, I'll go ahead and type in the IP address 172.16.1.11. That's the IP address for my web server. And let's take a look at how traffic flows. So I'm going to go ahead and turn on simulation mode in the bottom right, and I'm going to disable all my filters. Then when I edit my filters, I can turn on ARP, and under the miscellaneous tab, I want to turn on TCP and HTTP. Now that my filters are turned on, I'll go ahead and close this, verify it down here, which visible filters I'm going to see, and let's go back to my PC, and now we can generate that web request. So I'll click my go button, and I'll see 2 frames generated. The first frame is going to be my Ethernet frame with the broadcast address of all Fs. This is my ARP request. I'm trying to find the MAC address of the router. I know I need to send a packet to 172.16.1.11, but I need to forward that to my default gateway, so I need to find the MAC address of 192.168.1.0. This other frame is going to be a TCP request trying to find the web server, but I can't really send that because I don't have anything in my ARP table yet, so I don't know how to create that frame. So it's going to get dropped. So let's click ahead to the next step, and we'll see the TCP request just disappeared. And now my switch has received this broadcast, and it's going to forward it out all ports except the port it came in on. It's not going to send it back out 01. So in our next step, we'll see copies are sent to all the devices. PC1 and PC2 receive that broadcast. It's not for them, so they're going to drop it. Now the router gets it. It acknowledges that that ARP request is for it. So it's going to go ahead and send it back to the switch, and the switch is going to send it back to PC0. Now that PC0 knows the MAC address of router 0, it can go ahead and start to create that TCP three-way handshake. So now that unicast frame is going to go to router 0, and router 0 acknowledges that I need to forward it, but it doesn't know where to send it. So it has to drop this frame, and it's going to send a broadcast out, gig 001, trying to find the MAC address for 172.16.1.11. So it's going to send its ARP broadcast out, the switch will forward it out all ports, it'll get to server 0. Server 0 is going to send a response back, and now router 0 knows the MAC address for the web server. Once this is done, now PC0 knows the MAC address for its gateway, router 0 knows the MAC address for the web server, so now we can start that TCP three-way handshake, and let's just take a look at this frame. And we can see we've got an Ethernet frame going from PC0 with the correct source and destination MAC address. It's going to get forwarded to the router, and the router is going to take it and forward that TCP message. It's the same message at layer 3, but now my source address has changed to D002, and the destination is 293C, which is the MAC address of my web server. Next thing that's going to happen is it's going to get to the web server. The web server is going to send a response back, and we're going to establish that three-way handshake. Now that PC0 has created a TCP session between itself and server 0, it can create that HTTP packet. And inside here we'll see the layer 2 framing information, the source MAC address of 7013. The destination of the Ethernet frame is going to be the default gateway, 192.168.1.1, and its MAC address, D001. Notice here my source and destination IP are the IP address of the PC and the web server here, 172.16.1.11, but the Ethernet frame is destined to the router. And of course, now we're seeing the layer 4 information where we generated a source port randomly of 1025 and the destination port of 80. So our next frame, or our next packet, is going to, well, we'll see another TCP packet go through, but let's take a look at the web traffic also. And this in purple is our web traffic still, and it's going to go ahead and it's going to get forwarded to the web server. The web server is going to respond back because it knows the MAC address of the router. It doesn't need to do anything or receive that from its broadcast, the ARP request. And now our HTTP traffic will go through, and let's bring up the web browser and take a look at what happens once we get that frame. Now we've finally downloaded our web page. Now that we've successfully generated a web request, let's take a look at the ARP and MAC address tables of the PC and the router. So the first thing we'll look at is PC0, and you can see that PC0 has dynamically learned the MAC address of 192.168.1.1. That's the gig 000 of router 0. Next thing we want to do is let's take a look at the MAC address table of the switch. Now you can see that the switch has dynamically learned the MAC addresses for ports gig 01 and FA01. And lastly, let's take a look at that router. And in the ARP table of the router, you can see that the router has learned the MAC address for 192.168.1.11, that's the PC, and it's also learned the MAC address for 172.16.1.11. I hope you have found this video helpful in learning about MAC addresses, IP addresses, and ARP. If you enjoyed this video, please remember to like and subscribe, and thanks for watching.